Steganography is a very interesting way of hiding one's data by use of a cover information or inside of another file. Networking steganography, which will be the focus of this presentation, is based on the exploitation of current protocols and transport layers in communication mediums over networks. So what exactly is network steganography? Steganography in general can be thought of as the hiding information in other information by means of a steganogram. Historically, this has been done through images, files, songs, and text. Essentially what you are doing is hiding data, say random textual words for spying purposes, inside of another work. Network steganography, however, describes steganography that works through the exploitation of current network protocols and their inherent functionality. This would be things like the HTTP transfer protocols, TCP/IP, those types of protocols and network functionality. Generally, anything involving network steganography would exploit the flow of data over a network via packets, anything along those lines. Information can be hidden, as with ordinary steganography, in protocol control elements and manipulating the protocol's logic. Essentially, anything that can be exploited in terms of the inherent protocol functionality and how it works can be used to hide data using that protocol. And typically, network steganography is confined to a single protocol at any time. Using more than one would be inadvisable. So what are some types of network steganography? One of the most useful would definitely be the hiccups method, or hidden communication system for corrupted networks. This particular method is mostly suitable for WLAN environments, and basically it intentionally issues frames with wrong checksums to establish covert communication. A station would send a corrupted frame, and remaining hidden stations on the network would change their mode of operation to the corrupted frame mode. And for any observers, it would look a lot like hiccups. To transmit steganograms, hiccups replaces its payload of potentially corrupted frames, basically at the transmitter. Now, what this allows it to do is set up within the network a kind of hidden group. And this hidden group can now covertly send information back and forth in something of like real time. As long as someone using this particular type of system can keep the influence on frame error rate below what would be a suspicious level, you can effectively sit there and hide. Another type of network steganography is the lost audio packets technique. Essentially, lost audio packets, it modifies voice packets' time relations in order to force the receiver to discard select packets after intentionally delaying them. To transmit steganograms, LAC replaces the payload of what is an intentionally delayed voice packet at the transmitting computer or device, and this packet will be recognized as lost and dropped at the receiver. Once a delayed steganogram packet is dropped at the receiver would have LAC-aware software running that would extract the steganogram from the delayed voice packet. And that is essentially how you would be able to transmit bytes of data using a lost audio packet technique. Due to the nature of network steganograms, it can be very difficult to find out if someone on a network is actively using them, the techniques. Hiccups actively hides transmission within a network, whereas lost audio packet steganography only shows up if you catch the transmitter and the receiver having consistently timed lost data packets. And transmitted data may be encrypted or could be another part of a steganogram. In other words, you could end up with an endless encapsulation method of encryption and steganograms within steganograms. This type of behavior can plague any system that has a means of exploitation, and nearly any network protocol or transmission scheme would have a exploitation uh, vulnerability. The upsides to this are that network steganograms are actually a very secure means of data transmission if you take the time to properly cover your tracks and ensure that what you're transmitting is encrypted or is another part of an encrypted steganogram. All in all, network steganograms are a very interesting subset of steganography, and most likely going forward will make up the majority of steganographic techniques. And that concludes this presentation.